Some sounds are just the worst, like nails on a chalkboard or someone clearing their throat right before bed. And if you're like me, then you can't help but cringe at the sound of a baby being born or fingernails scraping down a blackboard. In fact, certain high-pitched sounds are so unbearable that they can trigger a whole body shudder response. So what makes some sound so awful? Well, it turns out we rate all a little bit tone deaf when it comes to sounds above 1000 hertz. Most animals can hear sounds within the range of 20 hertz to 20 kilohertz, but humans can only detect sounds from about 20 to 20,000 hertz. Somewhere in between those extremes are sounds that we find particularly grating. Our ears are most sensitive to sounds between 2000 to 5000 hertz. This sensitivity is linked to the anatomy of our auditory system. Sounds travel through the air as waves, and when they reach our ears, they're picked up by the outer ear and funneled through the ear canal to the eardrum. Once the eardrum is hit by sound waves, it vibrates, and those vibrations are sent to the middle ear, where they re-amplified by three tiny bones called the malleus, incus, and stapes. From there, the sound waves travel to the inner ear and hit the cochlea, which is filled with fluid and lined with hair cells that sense the movement of the fluid and convert the vibrations into electrical signals that get sent to the brain. Now, because these three little bones in the middle ear amplify the sound before it hits the cochlea, but that doesn't explain why we find some sounds worse than others. For example, we tend to dislike the sound of fingernails on a chalkboard more than the sound of fingernails on a desk. And that's because the material that the fingernails are pressing against makes a difference. When fingernails press against a rough surface like a chalkboard, they produce a squeak. That squeak is a complex sound with multiple frequencies, but it's dominated by a harsh sound in the 4000 to 6000 hertz range. On the other hand, when fingernails scrape a smooth surface, like when they drag across a desk, they don't produce a squeak. Instead, they create a thud, and that sound has fewer harmonics and less energy in the 4000 to 6000 hertz range. Even so, it's not just the sound itself, but also how we process that sound in the brain that contributes to how we perceive it. Sounds in the 2000 to 5000 hertz range activate two of the brain's worst-case scenarios, the fear center and the pain center, even though hearing that sound doesn't actually put us in danger. Researchers peg this as an evolutionary quirk. Sounds in this range often signal danger, like the scream of a siren or a drill or a chainsaw. So over time, we've learned to fear them. And while that might not be super helpful in the modern day, it does keep us safe when we're around power tools. When a scary sound enters the brain through the ear, it activates the amygdala, which throws our body into fight or flight mode. The amygdala then sends signals to other parts of the brain to initiate the appropriate response. In the case of the unpleasant sound, the response might be to cringe or cover your ears, which would protect them from something dangerous. Of course, covering your ears isn't always possible, like when you're watching a movie or listening to music, and for those times, the amygdala has another trick up its sleeve. It can trigger the release of neurotransmitters that cause physical sensations like goosebumps or shivers. That's why sometimes when you hear a really intense sound, you might feel a shiver run down your spine or the hairs on your arms stand on end. Your brain is essentially giving itself a little electric shock to grab your attention and trigger a response. Not everyone reacts to sound the same way. Some people are more sensitive to certain sounds than others are, which could be because of differences in how their brains process sounds or differences in their genetics. But that doesn't change the fact that certain sounds can reduce us to a shivering mess. So next time you find yourself cringing at the sound of fingernails on a chalkboard or something else, know that you're not alone. And now you know exactly what to blame. If you like this video, stay tuned for more.